Good morning. So today we are going to discuss regarding the topic worm propagation models. So to know why we need to study this worm propagation model, first it is very important to know which aspects that helps the worms to propagate faster. It is observed that the worms which are developed after 2001 are very speed in propagation. They infect the machines very fast. So modeling of this worm propagation is very important to know how exactly this worm propagates, and it is possible for us to take some remedial action to stop this propagation. So for that reason, it is very important to model or to create the model of worm propagation. Now to begin with, we'll talk regarding the creation of a simple epidemic model, which is, say, based on the way in which the infection spreads in a human being. Basically, it is a kind of a mathematical model which helps us to analyze way in which the worms or some kind of a disease that propagates in a human being. This simple epidemic model assumes that, say, there are only two categories of people, that is, either the individual is susceptible or he is infected. So the one category is set of people who are not infected, the other category is set of people who are infected by some particular disease. Since the category of disease is epidemic, so here the infected person has an ability to infect the uninfected person or a susceptible person. Once an infected person remains infected and does not recover, so there is a more possibility that he may infect the others. To understand this particular model, we will discuss how exactly this model is represented in a mathematical fashion. So in this model, we are representing n for the total population. N is representing all the persons. It includes both categories of people, the people who are infected by the virus, people who are not infected by the virus. So let IT be the number of, say, infected people. So out of this n, IT will be the people who are not infected by, IT will be the people who are infected by some kind of a disease. The total number of susceptibles, that means the number of people who are not affected by this virus or this disease, is, say, given by n minus IT, where n is total number of population, where IT is the infected population. So when you subtract this infected population from total, you will get the number of people who are susceptible, who are not yet infected by this virus. It is possible to infect them. So let beta be the infection rate. That is, beta is, say, initial infection rate that each infected person attempts to pass the infection to a beta susceptibles in 1 unit time. So beta is talking regarding how many people will going to get infected in 1 unit time. Now to know a set of people, that is a small category of people who are infected by already infected people, for that we are talking of using a infection rate that is obtained by multiplying with IT. IT is a set of people who are already infected, which gives you the total number of infection at 1 unit time. That is, say, at 1 unit time I am getting a small set of people, that is DI, which are infected by already infected people. So this term in this equation talks regarding way in which the infection is, the uninfected people are getting infected. So when I talk about beta IT from the perspective of, say, infinite population, that time this term will going to be absent. So this will not going to be a part of this equation, where I can simply say di is equal to beta it. But when it comes to a finite set of people, there is a possibility that, say, already infected people, they are also trying to infect the already infected people. They try to spread. So the spreading does not identify that this is infected person, this is not the infected person. The spreading takes to all set of people. So now, how many people who are not actually infected, we need to find it out. For that reason, we are taking out the people on which this particular disease, which is trying to, say, infect the already infected people. That term is indicated by this, and when I subtract this from 1, the complete thing, so that will give me a fraction of a people who are going to be not infected, will go to be get infected by this. So this term helps us to identify the people, fraction of the people who are not infected are getting infected by the infected people. So this gives you the outcome, this gives you to know how many people are infected. After simplifying this particular above equation, I am going to get this value which talks regarding the infection rate at time t. Now integrating above equation, I am going to get the value, that is the infected people at time t is equal to the number of people that are infected at time t will going to be given by this equation, that is I0 n divided by I0 plus n minus I0 e raised to beta t, where I0 indicates the people who are all already infected. In this case, IT is the fresh value, whereas I0 is the previously infected people. This model is used to find out the infected machines in the, say, in the computer science field. The crucial observation is that this simple epidemic model is fairly accurate in finding the number of infected machines in the first 15 hours of the outbreak of, say, especially the code red 1 virus. Basically, this model helped us to analyze the outbreak of code red 1 virus. There is one major issue with this simple epidemic model, that it takes only 2 categories of people into a consideration, that is the infected and non-infected. But when it comes to a real world, okay, so when it comes to a computer machines, we need one more category of say machines, say, which is talking regarding the one set of machines which are neither, say, which are infected and they are cured. Now they are, say, immune to this particular virus. Next, we are going to discuss regarding Kermit and Kermit model. So this particular model takes a 3 category of people into a consideration, or 3 category of machines into a consideration. So Kermit and Kermit model basically talks regarding 3 category of people. Here, whenever I say a people, it indicates a machines also, because we are trying to model, we are trying to use the models that are used in the human beings to analyze the machines that are getting affected. So in this particular model, there are 3 categories of people: those who are susceptible, so that we call them as the people in S state, and those who are infectious people, those who are already infected by the virus, and the third category of people, they are neither, they are not infected nor susceptible. So these are the category of people who are already infected and cured. So normally when it comes to a computer world, so there, whenever some bigger organization, when they notice when some machines of their organizations get affected, so normally these organizations use antivirus softwares, and in case if they find the machines which are if they get infected by some particular virus, they try to attach a patch to overcome the effect of those viruses or to make machines virus free. So normally most of the antivirus softwares, they provide, they have a facility of providing the patches. Every time and now they release the patches to overcome new virus or worms attack. So because of that, we are talking of three category people. So that is the people who are susceptible, yes, those people who are infected, they are I, the people who are say infected and got cured, or sometimes they are very immune to this infection. So those are in the third category, that is T. So by using these three different set of peoples, we'll try to create the Kermit and McKendrick model. This first figure talks regarding the simple epidemic model, that is SCM model, where susceptibles try to infect themselves and try to be in a susceptible state, or they get infected by receiving the infection. Here we are not talking about the third category of people, so who are moving from this state to a new state. So normally the people who are there in the susceptible state, if they are not getting infected by any virus, they stay in the same state, and moment they get infected, they move from S state to a I state, that is infected state. So they try to stay there in that state in case if no remedial actions are taken. In case any remedial actions of the type by attaching a patch or so they will move from this I state to a T state. Once they move to a T state, they stay in a T state because they are already aware regarding how to cure the virus. So they remain in this particular state when it comes to our machines. So this is a model of say KM model, we call it as a KM model, but I will talk regarding one more model that is much more realistic compared to that of KM model. So which is talking regarding a one more state, that is P2 state. So there is no much difference between a P2 and a P1 state, but in this case, say a P2 are the machines which are going to be patched when they are in a susceptible state. Say basically in KM model, say it is basically best suited for that say code red spread comparison to a simple epidemic model, but it has a few shortfalls. Say to overcome those shortfalls, the third model, which is more realistic, has been explained over here. There is a possibility that the people who are not getting infected, once an organization knows regarding the virus attack, and it tries to cure the machines which are infected by the virus by using a patch, and it may also take some precautionary measures by adding up patches to a machines which are not yet infected. So that means it is not possible for this virus to infect these machines because already they are immune. It is something like say providing say vaccines to the people who are not yet infected by some kind of a disease. So you are preparing the human being to fight against that a newer virus. So where here you are say already you are protecting a person by already you are protecting that machine by applying a patch from this virus. So this patch has an ability to block this virus. Next we will going to discuss regarding topological worms. Topological worms are there are two categories of topological worms. One is email worms, a second one is P2P worms. So topological worms are called topological worms mainly because they are represented by the graphs, and nodes in these graphs are vulnerable machines. So basically this topological worms spread will going to be represented in the form of a graph, where talking regarding this graph represents the set of vulnerable machines which can be infected. These worms have focus targets. Their immediate targets are their neighbors. In turn, they spread infection to their neighbors and so on. Thus, the rate of spreading is potentially faster than the internet scanning worms. Which typically scan the IP addresses and try to attack the machines. So these topological worms spread either through emails or the techniques that are used in a P2P. We'll discuss regarding these two category worms in detail. The email worms propagate normally through infected emails. The victim receives the email that comes from the trusted party or some particular, say, known source. The victims, when they see a file that is present in the email, or sometimes it may be a kind of a link, say URL. So when he clicks or when he say receives that file, the file, so normally they will be of, say, very the file names will be of created by using some, say, very catchy words and all. So whenever he clicks on those files, the VB script gets executed. Normally they will be of the type exe files, so that it makes the moment you click on those file links or sometimes in the file itself, it gets executed on your machine. By doing so, it infects your machine. These email worms not only affect the machine on which they get the email file gets executed, they will also take the contact list of the victim, contact list email lists from the victim's mailbox, and moment they get all the information, different set of people's information from that list, it tries to propagate to them. So this is how they move from one machine to another machine. Moment they go to another machine, there also they do the same task, getting the say list of email IDs, and using that it tries to go to our next machines. Most of these email worms exploit the fact that documents created by certain word processor embedded software macros in them, and these macros execute when document is opened. The best example for this is Melissa macro worm. So basically it was designed to extract a 50 person's name from the victim's address book. By taking those information out of the victim's address book, they try to propagate to the 50 new machines. So way in which they infect the new machine is by executing these macros on the machine on which moment they reach some different machines. One more category of this topological worms is P2P worms. A P2P in P2P network, say it is massively, you know that it is a distributed kind of a network. Say each peer, here there is no server as such and no client. Every machine acts on its own as a server, and the machine one which is receiving the communication from that machine acts like a client, and the same client may act like a server to another machines. Okay, so this is what the way in which the P2P machines works. And basically this P2P network is developed to share images, videos, songs and movies. I think most of you are already aware regarding such a P2P, say, network. That is, the best example for that is torrent. You can also be a part of that P2P with the help of torrent. Nowadays in India, that torrent is banned, so you are not allowed to use those things. In P2P network, each peer maintains within itself a shared folder of files that is willing to share with the others. Users do not download the files from central server but from their peers located across the globes. There are immensely popular as well as evidenced by the fact that very large portion of the internet traffic is comprised of P2P packets, because basically this P2P is meant for exchanging, say, videos and images. to know how exactly the P2P worm spreads, it is important to know how exactly the P2P network operates. In P2P networks, use a overlay network, which is a logical network of peers. Basically, this particular network is created on the below network, okay, which is kind of a logical network. So here two peers are said to be a neighbors at any given point of time if they are active TCP connection between them. So basically we are not saying that neighbors has to be geographically nearer to each other. They may be at any place, but say we are saying they are logical neighbors. We are calling them as a logical neighbors. Here are the potential ways that P2P worms may spread. So this is where you see how exactly P2P network the worms spreads. This figure demonstrates how exactly the files are getting exchanged in a P2P network. So I talk about a machine A. These are the peers of machines A. So these are the immediate neighbors of A. Say for example, A is downloading some movie file. So when he wants some part of the file, okay, which is not currently available with the party one with whom he is getting that file. So what he will do is he will try to get it from the neighbors. So for that he sends a query to all his neighbors. So when these neighbors, when they don't have that particular say file with them, they try to help A by querying their own neighbors. Say for example, in this case A is querying this machine. When it does not have that file, it queries the other machines. So like this, queries are created in this network. So in this example, we are assuming that the files are present with B and C. So moment the request for that particular file goes to a B through query 3, which is generated by this particular neighbor of B. So it replies back to it, and then the file will be transferred to A. So since in this figure I am assuming that both B and C are having that requested file. So now it is up to the A has to download that file from one of them. So normally A will going to decide based on some kind of a policy what P2P adopts. Based on that, it selects one of the peers for downloading that file. This idea of exchanging of file in a P2P network is used for propagating the worms. So when it replies back to A, during that time the IP addresses are also getting exchanged. Now we will see how exactly the communication with the peer will be utilized by the worms to spread. Say one of the simplest for way of spreading the worms in this network is if malicious peer responds positively to any of the query that is made by A. Say for example, if C is malicious. So what happens? Say in this example I will take B only as a malicious. So if B is a malicious, he may respond to A in a positive way, saying that he is holding the file. So now B will going to respond with the file one which contains the worms to A by changing the name of the file, so that what A is requested, it changes the file name to that and sends that infected file to A. Now by doing so, see, A does not have any mechanism to identify this is a malicious one. He treats him as a P and he tries to get the file that is transferred by B. Now what happened? The infection has spread from B to A. And in the later part, in this P2P network, when A starts acting like a server for the file what it is holding, that time it spreads the virus to other devices. This technique of spreading, we call it as passive way of spreading, because here the file will going to come to A only because his request reaches a such malicious peer. So that is the reason we are calling this as a passive kind of attack. The second category is second category of worms are of the type active. So these worms does not wait for a request to come from others. What they do is they will use the readily available list with once it joins a peer-to-peer network, it will going to get a list of neighbors that are associated with it. Moment it comes to know regarding the neighbors, rather than waiting for the request to come from the neighbors, it tries to propagate, it try to push the worm file to those neighbors. And here it does not wait for going for scanning for IP addresses, what normally happens in the internet worms. Here it is not even bother regarding scanning. It has already list of IP addresses of its neighbors. Using them, it propagates the file. This kind of a act, we call it as active way of propagating P2P worms. So this is all regarding topological worms. And in the next class, we'll going to discuss regarding botnets. Thank you very much.